For all the discoveries we've made, the universe is still filled with puzzles, paradoxes, and quiet mysteries that no one can fully explain. Some are cosmic, stretching across galaxies and black holes. Others live here on Earth, in the oceans, the atmosphere, and even in our own bodies. These unanswered questions remind us that science is not a book of final truths, but an endless story still being written. Each mystery holds a doorway to wonder, a reminder that we are explorers in a universe far bigger than we can yet comprehend. If you enjoy drifting off to scientific wonders, feel free to like and subscribe or simply share your thoughts down in the comments. It helps others find their way here too. But for now, let these questions carry you. And if you're ready, let's begin. 1. Why the universe exists at all. We still don't know why the universe exists at all. It seems like the most basic question imaginable. Why is there something instead of nothing? And yet science has no answer. Physics can describe how the universe behaves once it exists. Cosmology can trace events back to the Big Bang. But why there is a universe at all, why there are laws that allow it to exist, remains unsolved. Quantum physics suggests that what we call nothing is not truly empty. Even the vacuum of space teems with activity, fleeting particles that flicker into being before vanishing again. Some physicists suggest that the universe itself may have arisen in the same way, that absolute nothingness is unstable and something must always emerge. Others argue that perhaps our universe is only one of countless universes in a vast multiverse, each popping into being with its own laws. But if that's true, we are only pushed back to a deeper question. Why should the multiverse itself exist? Philosophers sometimes propose that existence is simply the natural state, that non-existence is impossible. Perhaps reality in some form must always be. But these are ideas we cannot test. No telescope, no particle collider can measure why there is being instead of nothing. Every other question in science rests upon this one. Every star in the sky, every atom in your body, every law of nature, all exist on a foundation we cannot explain. The fact that reality is here at all remains the deepest mystery we face. 2. The spark that set the cosmos in motion. The spark that set the cosmos in motion remains a mystery. We can trace the universe's story back nearly 14 billion years to an age when it was a hot, dense fireball. We call this beginning the Big Bang. But what actually caused it? That remains unknown. Cosmologists have pieced together a detailed history from the moment the universe was only fractions of a second old. In that first instant, rapid expansion, called inflation, may have blown space itself wide open. But what triggered inflation? Why did it start? And why did it end? These questions remain unanswered. Some theories imagine the Big Bang as a quantum fluctuation, a tremor in the fabric of reality that gave rise to space and time themselves. Others suggest that the Big Bang was not the first event, but only one moment in a cycle of births and deaths, with universes expanding, collapsing, and beginning again. What complicates the question further is time itself. If the universe includes the birth of time, then asking what came before may not even make sense. Our instruments, the Hubble Space Telescope, the Planck satellite, and the new James Webb, give us snapshots of the infant universe. But none can peer into the first instant itself. We know the universe began. We can measure its age, chart its growth, and study its afterglow. But the spark that set the cosmos in motion, the true first cause, is a mystery still hidden in the dark. 3. The arrow of time. Time always flows forward, but no one can explain why. Every moment, the present slips into the past. We remember yesterday, but not tomorrow. A broken glass never leaps back together. Heat moves from hot coffee into the air, but never the reverse. Time in our experience only flows one way. This is called the arrow of time. What makes it strange is that the fundamental laws of physics don't require this. At the smallest scales, particles can move forward or backward in time with equal consistency. The equations are symmetrical. Nothing in them demands that time should only advance. And yet, our entire world depends on this one-way street. Scientists often connect the arrow of time to entropy, the tendency for disorder to increase. The universe began in an exceptionally ordered state and has been running down ever since. But why did it begin that way? Why should the cosmos have started in such a low entropy condition that time could even have a direction? Some physicists think the arrow of time might emerge from the way information spreads. Others suggest it is tied to the expansion of the universe itself. But none of these explanations are complete. Time's direction is something we live inside of every second of our lives. And yet why it flows forward and only forward remains one of the most haunting mysteries of science. 4. Dark matter. Most of the universe is made of something we cannot see. When astronomers measure the way galaxies spin, they find something strange. Stars near the edges move far too quickly, as if held by an invisible force. By all logic, those stars should drift away into space. Instead, they remain bound. The conclusion is inescapable. Most of the mass in the universe is not visible to us. We call it dark matter. Dark matter neither glows nor absorbs light. Telescopes cannot see it directly. Yet we know it must be there because its gravity shapes everything around it. It holds galaxies together, bends the paths of starlight from distant clusters, and leaves faint ripples in the pattern of the cosmic web. So, what is it? Scientists have searched for decades. Some think it is made of undiscovered particles, perhaps WIMPs or weakly interacting massive particles. Others suggest axions, ghostly particles that barely interact with ordinary matter. There are even theories that dark matter could be black holes formed in the earliest moments after the Big Bang. Despite enormous effort, we still don't know. Experiments buried deep underground wait for a passing dark matter particle to collide with a single atom. So far, none have. For now, this hidden mass, 5 times more abundant than ordinary matter, remains one of the universe's greatest unsolved mysteries. 5. Dark energy. An invisible force is stretching space apart faster and faster. In the 1990s, astronomers studying distant supernova expected to see the universe's expansion slowing down. After all, gravity should be pulling galaxies back together. Instead, they discovered the opposite. The universe is not just expanding, it is accelerating. This means some unknown energy is embedded in space itself, pushing galaxies away from each other at ever-increasing speeds. We call it dark energy, though the name is only a placeholder for our ignorance. Dark energy makes up nearly 70% of the entire cosmos. Yet we don't know what it is. One idea is that it is a property of the vacuum, a kind of constant energy present in empty space. Another possibility is that it points to new physics, perhaps a dynamic field that changes over time. Some theories even suggest it could be a sign that our understanding of gravity itself is incomplete. What makes the mystery even more unsettling is its consequence. The universe's fate depends on this invisible force. If dark energy remains constant, galaxies will drift farther apart until only empty space is left. If it grows stronger, it could eventually tear apart galaxies, stars, and even atoms. We can measure its effects, but we cannot see its true nature. Dark energy is the unseen hand shaping the ultimate future of the universe. I'll pause here, intro plus 1 to 5, so you can confirm the formatting style works before I continue with 6 to 10.6. The fine-tuning problem. The laws of physics seem tuned for life in ways we don't understand. The universe appears balanced on the knife's edge. If gravity was slightly stronger, stars would collapse too quickly. If it were weaker, galaxies might never form. If the electromagnetic force were different by a fraction, atoms would not bind together. Even the tiniest changes in the constants of physics could erase the possibility of life altogether. This puzzle is known as the fine-tuning problem. Why should the laws of nature have exactly the values they do? There is no obvious reason for gravity, electromagnetism, or nuclear forces to take the strengths they have. And yet, if they were different by even a little, our universe would be lifeless. Some argue this is coincidence. Others suggest that countless universes exist, each with different laws, and we simply live in the rare one where life is possible, a cosmic lottery win. Another idea is that there may be a deeper principle, still undiscovered, that forces the laws to take these exact values. For now, we cannot say. But when we look around at stars, planets, and the fact that we can even ask this question, we are reminded that the universe feels improbably, uncannily suited for life. And why that is, so remains one of science's greatest mysteries. 7. Is the universe infinite? No one knows if the universe goes on forever or ends somewhere. The observable universe is vast, about 90 billion light-years across, but we cannot see beyond it. Light has only had so much time to travel since the Big Bang, and so there is a horizon we cannot look past. But what lies beyond that edge? One possibility is that the universe is infinite, stretching endlessly in all directions with no boundary at all. If so, then space may contain an unending number of galaxies, stars, and perhaps even other Earth-like worlds. Another possibility is that the universe is finite but unbounded, like the surface of a sphere. In such a universe, if you could travel far enough in one direction, you might eventually return to your starting point. Scientists search for answers in the cosmic microwave background, the faint afterglow of the Big Bang. Its patterns might reveal the universe's shape. So far, the evidence suggests that the universe is very nearly flat. But this does not settle the question of whether it is infinite. For now, we don't know if the cosmos stretches without end, or if it loops back on itself. The true size and shape of the universe remain hidden, just beyond our reach. Beyond the horizon of what we can see, there may be endless unknowns. 8. The unobservable universe. When we look into space, we are also looking into the past. The most distant galaxies we can see are sending us light that has traveled for over 13 billion years. But beyond that lies a region forever hidden, the unobservable universe. This cosmic horizon is not like a physical wall. It is a limit set by the age of the universe and the speed of light. Beyond it, reality continues. But we can never know exactly what is there. Perhaps it is much the same. Galaxies, stars, and planets stretching far beyond our sight. Or perhaps it is radically different, with regions governed by different conditions or even different physical laws. Some theories of inflation, the rapid expansion thought to have occurred right after the Big Bang, suggest that our observable patch is just one bubble in a much larger reality. If true, the vast majority of the universe lies forever beyond what we can measure. We are bound within a cosmic island. The sky we see is only the smallest fraction of what may exist. The rest of the universe is out there, silent and unreachable, a permanent unknown. 9. The multiverse hypothesis. Some scientists believe there are other universes, but we cannot prove it. The idea of the multiverse is one of the boldest in modern science. It suggests that our universe may not be unique, but one of countless others. Each universe could have different laws of physics, different histories, even different numbers of dimensions. The concept arises naturally in some theories. Inflation may create bubble universes, each budding off with its own conditions. String theory predicts a vast landscape of possible realities. In such scenarios, our universe is simply one outcome among many. This could even explain fine-tuning. We live in a universe suited for life because only in such universes can observers exist. But there is a problem. If other universes exist beyond our cosmic horizon, we may never be able to observe them. No light or signal could ever cross the boundary. This makes the multiverse both fascinating and controversial. It stretches the definition of science because an idea we cannot test may never be more than speculation. Still, the possibility that reality is larger than our universe, perhaps infinitely larger, is one of the most intriguing mysteries in physics. 10. The nature of space and time. Space and time may be woven from deeper rules we haven't discovered. Einstein's general relativity shows us that space and time are not fixed backdrops, but flexible and dynamic. They bend, curve, and stretch, shaping the paths of planets and the flow of light. But what at the deepest level is this fabric made of? At the smallest scales, relativity and quantum mechanics clash. Space and time seem smooth in relativity, but quantum theory suggests that everything should be grainy, fluctuating, and uncertain. Reconciling these two views is one of the greatest challenges in science. Some ideas suggest that space and time are not fundamental at all. Instead, they may emerge from something deeper, perhaps a network of quantum information or entanglement patterns that give rise to geometry. In this picture, what we call space-time is like a surface, and underneath lies a more basic reality we cannot yet see. Others wonder if time itself is even real, or if it is an illusion created by deeper processes. If so, our most basic intuition about reality would be wrong. Space and time feel like the stage on which the universe unfolds. Yet the stage itself may not be what it seems. What they truly are remains one of the most profound unanswered questions in science. 11. Quantum paradoxes. At the heart of physics lies quantum mechanics, a theory that works flawlessly in predicting experiments but makes little intuitive sense. Particles can exist in superpositions, being in multiple states at once. They can become entangled, influencing each other instantly across vast distances. The act of measurement itself seems to change reality. The famous double-slit experiment shows this vividly. A single electron behaves like a wave, passing through two slits at once, interfering with itself. But when observed, it suddenly acts like a particle, choosing one path. Does reality depend on whether it is watched? No one can fully explain why the quantum world works this way. Some interpretations suggest many worlds, where each possibility plays out in parallel universes. Others propose hidden variables or that consciousness itself collapses the wave function. Quantum mechanics has given us computers, lasers, and modern electronics. Yet at its core, it remains mysterious. Why nature behaves this way, whether there is a deeper reality beneath it, is one of science's strangest puzzles. 12. Why gravity is so weak. Gravity is the weakest of all known forces, yet it shapes the universe. The electromagnetic force is 10 or 36 times stronger. You can lift a paperclip with a small magnet, overcoming the pull of an entire planet. And yet gravity holds galaxies together and sculpts the cosmos. Physicists don't know why gravity is so much weaker than the other fundamental forces. This is called the hierarchy problem. Some theories suggest that gravity is not weak at all, but that it leaks into extra dimensions beyond the three we know. Others propose new particles or fields that dilute its strength. Despite centuries of study, from Newton to Einstein to modern physicists, gravity remains partly a mystery. We can describe how it works, bending space and time, but why it is so feeble compared to the other forces is still unanswered. This weakness is both a puzzle and a gift. If gravity were stronger, stars might burn out too fast or collapse quickly. The universe might not allow life at all. The mystery of gravity's gentle hand is one of the deepest questions in science. 13. The unification problem. Physics has two magnificent theories. Einstein's relativity explains the very large, stars, galaxies, the bending of space. Quantum mechanics explains the very small, atoms, particles, probabilities. Each works perfectly in its domain, but together they clash. At black holes and the Big Bang, both theories are needed, but they give contradictory answers. Relativity sees smooth spacetime. Quantum theory sees jittery uncertainty. We need a theory of quantum gravity to unite them, but none has succeeded yet. String theory and loop quantum gravity are leading candidates. String theory imagines particles as tiny vibrating strings in higher dimensions. Loop quantum gravity pictures spacetime itself as woven from discrete loops. But no experiment has confirmed either. The unification problem is not just mathematical. It asks whether our two great pictures of reality are merely parts of a larger whole. Until we solve it, the deepest workings of the cosmos remain hidden. 14. Black hole information paradox. Black holes are cosmic traps from which nothing, not even light, can escape. According to Einstein, they are defined only by mass, spin, and charge. But quantum mechanics insists that information cannot be destroyed. Here lies the paradox. When matter falls into a black hole, what happens to the information about it? If the black hole evaporates over time, as Stephen Hawking proposed, then the information seems to vanish. But this violates the fundamental rules of quantum physics. Some theories suggest the information is somehow encoded in the radiation black holes emit. Others propose that it is smeared across the event horizon, a hologram of what fell in. But no one knows for sure. This conflict between relativity and quantum theory plays out on the edge of black holes. Solving it may unlock the path to a deeper understanding of reality itself. 15. What lies inside a black hole? Beyond the event horizon of a black hole lies a region where our understanding of physics breaks down. Relativity predicts that all the mass collapses to a singularity, a point of infinite density and zero volume. But infinities are usually a sign that our equations are incomplete. What truly happens inside a black hole is unknown. Some theories suggest that spacetime ends, that nothing exists beyond the horizon. Others imagine that black holes could harbor new universes budding off from ours. Some physicists propose that the core may be made not of a singularity, but of exotic states of matter we cannot yet describe. We cannot see inside a black hole. No light can escape. But by studying their effects on the outside universe, and by probing the mathematics, scientists hope to glimpse the truth. For now, the heart of a black hole remains hidden, the most secret place in the cosmos. 16. Wormholes and the possibility of time travel. General relativity allows strange solutions called wormholes, tunnels through spacetime connecting distant points. In theory, one could step into a wormhole and emerge light years away, or even at another time. But are wormholes real? They may require exotic matter to hold them open, something with negative energy density. No such material has been found. Even if wormholes could exist, they may be unstable, collapsing too quickly for travel. Time travel through wormholes raises paradoxes. Could you go back and change the past? Physicists debate whether the laws of reality would somehow prevent contradictions. For now, wormholes remain in the realm of theory, fascinating possibilities on paper. Whether they exist in the universe and whether they could ever be used is still unknown. 17. The nature of singularity. At the center of black holes and at the moment of the Big Bang, equations point to singularities, places where density and curvature become infinite. But what does that really mean? Singularities are signals that our theories have reached their limit. Physics as we know it cannot describe them. A complete theory of quantum gravity may smooth them out, revealing a truer picture. Are singularities real, physical things? Or are they simply artifacts of incomplete equations? Some suggest that nature never truly allows infinities, and that a deeper law must prevent them. For now, the singularity remains a symbol of mystery, the place where our understanding falls apart. 18. The first stars and galaxies. We can look back in time nearly to the Big Bang, but the era of the first stars remains hazy. After the universe cooled, darkness reigned until gravity gathered clouds of hydrogen and helium into the first luminous giants. When exactly did these stars ignite? How did they cluster into the first galaxies? The James Webb Space Telescope has begun peering into this epoch, finding galaxies that seem surprisingly mature, shockingly early. This challenges our models of how quickly structure could form. These first stars were likely massive, burning hot and fast, seeding the cosmos with heavier elements when they exploded. Without them, planets and life could not exist. Yet many details remain unknown. The dawn of stars and galaxies is the hidden chapter in the story of the universe. 19. Why galaxies form spirals. Many galaxies, including our own Milky Way, take the shape of elegant spirals, arms curving gracefully around a bright core. But why do they form this way? Gravity pulls stars together, but the spiral pattern is not simply material being stretched out. It seems to be a wave, a density pattern moving through the galaxy, gathering stars as it goes. The exact dynamics are still debated. Interactions with other galaxies, dark matter halos, and the behavior of interstellar gas all play roles. But no single explanation is complete. The spiral arms are both beautiful and mysterious, reminders that even familiar shapes in the night sky hold questions we cannot fully answer. 20. Fast radio bursts and other cosmic signals. In the last 2 decades, astronomers have discovered brief, powerful flashes of radio waves from deep space. These fast radio bursts last only milliseconds, yet release as much energy as the sun emits in days. Their origins remain unknown. Some repeat, while others are one-time events. They may come from magnetars, highly magnetic neutron stars, or they may be produced by phenomena we have not yet imagined. Fast radio bursts join a list of other cosmic signals we do not fully understand. Pulsars discovered in the 1960s, mysterious gamma-ray bursts, ultra-high-energy cosmic rays. Each is a message from the universe, written in a language we do not yet understand. They remind us that the cosmos still has surprises waiting to be discovered. What will be the ultimate fate of the universe? Will it expand forever, growing colder and emptier until nothing remains but faint radiation? Or will gravity eventually slow the expansion, causing the cosmos to collapse back into a fiery crunch? The discovery of dark energy complicates this picture. If it remains constant, the universe may end in a heat death, where stars burn out and black holes evaporate, leaving eternal darkness. If dark energy grows stronger, it could end in a big rip, tearing apart galaxies, stars, planets, and even atoms. We do not yet know the answer. The fate of everything depends on the nature of forces we do not yet understand. The universe may last forever, or it may have an end. For now, the final chapter is unwritten. 22. Cosmic inflation. Cosmic inflation is the idea that in the first trillionth of a second after the Big Bang, the universe expanded faster than the speed of light. This explains why the cosmos is so uniform on large scales and why space appears flat. But what caused inflation? What field or particle drove it? And why did it stop? These remain unsolved mysteries. Some theories propose an inflaton field, a new type of energy that briefly dominated reality. Others imagine eternal inflation, with new universes budding off endlessly. We see hints of inflation in the patterns of the cosmic microwave background, but the detailed mechanism remains hidden. Inflation solved puzzles, but it left new ones in its place. 23. Baryon asymmetry. The universe is made of matter, not antimatter. But according to physics, the Big Bang should have produced equal amounts of both. If that were true, they would have annihilated each other, leaving only light. Yet here we are in a universe of matter. Why did matter win? Something must have tipped the balance, some asymmetry in the laws of physics. Experiments search for tiny differences in the behavior of particles and antiparticles, clues to why the universe exists at all. So far, the mystery remains. The dominance of matter over antimatter is one of the reasons anything exists. Without it, there would be no stars, no planets, no people. 24. The nature of neutrinos. Neutrinos are ghostly particles that pass through us by the trillions every second, barely interacting with anything. They have tiny masses, but we do not know exactly how small. Do neutrinos get their mass from the Higgs field, like other particles? Or do they hint at new physics? Are they their own antiparticles, as some theories suggest? Neutrinos come in 3 types, or flavors, and they oscillate between them as they travel. This strange behavior won the Nobel Prize, but it remains mysterious. Understanding neutrinos could reveal secrets about the earliest moments of the universe. 25. The Higgs boson's true nature. The discovery of the Higgs boson in 2012 completed the standard model of particle physics. This particle gives mass to others through the Higgs field, but mysteries remain. Why does the Higgs boson have the mass it does? The equations suggest it should be far heavier or far lighter. Its measured value seems unnatural, as if delicately balanced. Some physicists think the Higgs is a window to deeper physics, perhaps supersymmetry or hidden dimensions. Others wonder if it is part of a larger family of particles. The Higgs answered one question but opened many more. It is a clue to mysteries at the foundation of matter. 26. The possibility of supersymmetry. Supersymmetry is a proposed extension of physics where every known particle has a heavier partner. It would help explain dark matter, unify forces, and stabilize the Higgs boson's mass. For decades, physicists searched for evidence at particle accelerators like the Large Hadron Collider. So far, none has been found. If supersymmetry is real, its particles may simply be beyond our reach. Or perhaps the idea itself is wrong. The absence of evidence has left physicists puzzled. Supersymmetry remains an elegant, unproven possibility, a vision of a deeper symmetry in the laws of nature. 27. Are there extra dimensions? We experience 3 dimensions of space and 1 of time, but some theories suggest more. String theory, for example, requires up to 11 dimensions. If these extra dimensions exist, they may be curled up, hidden on scales too small to see. Or they may stretch large but remain invisible to us. Some experiments search for signs of dimensions in high-energy collisions or in tiny deviations in gravity's behavior. None have been found yet, but if extra dimensions exist, they could explain mysteries from gravity's weakness to the nature of dark matter. The true shape of reality may be stranger than we know. 28. The search for a theory of everything. Scientists dream of a theory of everything, a single framework that unites all forces and particles. Einstein sought it but never found it. Today, string theory is a leading candidate, but it remains unproven. A true theory of everything would unite relativity with quantum mechanics, explain dark matter and energy, and reveal the deepest laws of the cosmos. But perhaps such a theory is beyond our grasp. Perhaps reality is not governed by a single elegant law, but by layers of emergent rules. The search continues. The dream of a theory that explains it all remains one of science's greatest quests. 29. The limits of knowledge. Are there limits to what humans can know? Our brains evolved to survive, not to grasp infinite complexity. Perhaps some truths of the universe are forever beyond us. Quantum mechanics already stretches our intuition. Cosmology deals with scales far beyond our experience. There may be aspects of reality we can never measure, hidden beyond horizons or too small to probe. Yet science has constantly pushed boundaries once thought impossible. Whether limits are real or only temporary is itself an open question. The mystery is not just the universe, but the human mind's place within it. 30. Why the laws of physics exist. We can describe the laws of physics with astonishing precision. But why do they exist at all? Why these laws and not others? Some suggest the laws are simply brute facts, requiring no explanation. Others propose they emerge from deeper principles or mathematics. In the multiverse view, every possible law exists somewhere, and we live in the one that allows us, but we do not know. The existence of laws themselves, rules that shape reality, may be the deepest unsolved mystery of all. 31. The nature of mathematics. Mathematics describes the universe with uncanny accuracy. Equations written on paper predict the motions of planets, the behavior of particles, even the shape of space and time. But why should this be so? Is math something humans invented, a language we created to describe patterns? Or is it discovered, a fundamental part of reality that exists whether or not anyone is there to see it? The unreasonable effectiveness of mathematics, as physicist Eugene Wigner called it, remains unexplained. Why does a set of symbols invented in the mind map so perfectly onto the laws of nature? This mystery touches both science and philosophy. Mathematics feels at once like a creation of thought and a key to the deepest truths of the universe. 32. Randomness and chance. Does true randomness exist in the universe, or is everything determined by hidden rules? Quantum mechanics suggests that events at the smallest scales happen by chance. The exact moment a radioactive atom decays, for example, cannot be predicted. But is this randomness real, or does it hide deeper causes we cannot see? Philosophers have long debated whether the universe is fundamentally deterministic, or whether chance is woven into its fabric. Randomness shapes evolution, mutation, and the roll of dice. It influences everything from weather patterns to quantum experiments. But what it really is, whether it is genuine unpredictability or just complexity beyond our grasp, is still unknown. 33. The flow of information. Information seems to be as fundamental to reality as matter and energy. It is conserved in quantum processes. It may even be the foundation of space-time itself. Black hole paradoxes revolve around the fate of information. Quantum entanglement shows that information can be shared instantly across distance. The entire universe may be understood as a vast web of information exchange. But what is information really? Is it physical, encoded in particles and fields? Or is it abstract, a measure of possibilities? Scientists are only beginning to explore this question. The flow of information may hold the key to uniting physics and unlocking the mysteries of the cosmos. 34. The nature of consciousness. How does matter give rise to mind? Neurons in the brain fire electrical signals. Chemicals pass across synapses. But from this emerges thought, awareness, and a sense of self. No one knows exactly how this happens. Consciousness remains one of the greatest mysteries in science and philosophy. Some propose that it arises from complex computation. Others suggest that consciousness may be a fundamental property of the universe, not reducible to simpler parts. We all experience it directly, yet we cannot explain it. The mind observing itself remains one of the deepest enigmas of existence. 35. The purpose of dreams. Why do we dream? Every night our brains weave strange narratives, often vivid, sometimes disturbing. Dreams may help process memories, rehearse threats, or regulate emotions, but their true purpose is uncertain. Some scientists see them as random byproducts of brain activity during sleep. Others believe they play a vital role in creativity and problem-solving. Cultures throughout history have seen dreams as messages from gods or glimpses of other worlds. Even today, the science of dreaming is incomplete. Why we spend hours each night in this shadow reality is still not fully understood. 36. The nature of memory. Memory defines who we are, but how it works remains mysterious. We know that experiences are stored in networks of neurons, strengthened by repetition. But how exactly does the brain encode, store, and retrieve the richness of lived experience? Memories are not perfect recordings. They shift, fade, and sometimes invent details. Why do some memories last a lifetime while others vanish in days? Why do scents or songs trigger vivid recollections long forgotten? The molecular and electrical basis of memory is partly known, but the full picture, how moments become part of the self, remains one of science's great puzzles. 37. The mystery of emotions. Emotions color every human experience. Joy, sorrow, anger, and love arise from the brain. But how and why? Are they purely biological survival tools, helping us navigate social life, or do they point to something deeper about consciousness? Neuroscience can trace brain regions involved in emotions. Hormones like dopamine and serotonin shape our moods. But why feelings exist at all, beyond simple stimulus and response, is unclear. Emotions drive art, culture, and human connection. They are central to what it means to be human, and yet their essence remains elusive. 38. The source of creativity. Where do new ideas come from? Creativity allows humans to imagine, invent, and create beauty. But how does the brain generate something entirely new? Scientists study the interplay between the conscious and unconscious mind, between logic and imagination. But there is no full explanation for the spark of insight, the sudden arrival of inspiration. Creativity seems to emerge from networks in the brain, but it cannot be reduced to simple processes. It is a uniquely human mystery, one that has shaped culture and progress for millennia. 39. The experience of déjà vu manie. People have felt it, the eerie sense that a moment has happened before, though it has not. This is déjà vu. Some theories suggest it is a memory glitch, the brain accidentally processing the present as if it were a memory. Others propose it is linked to subconscious perception, or to the brain's attempt to predict events. No explanation is complete. Déjà vu remains a fleeting, mysterious experience, a reminder that the brain is not always transparent to itself. 40. The placebo effect. The placebo effect shows the power of belief. Patients given a sugar pill, told it is medicine, often experience real improvements. Pain eases, symptoms diminish, even physical changes occur. Why does this happen? The brain's expectations seem to trigger healing responses, releasing chemicals that reduce pain or alter perception. But the exact mechanisms are unclear. The placebo effect reveals that the mind and body are deeply intertwined. Belief alone can shape biology. Understanding it better could revolutionize medicine, but for now, much of it remains unexplained. 41. The purpose of sleep. We spend about a third of our lives asleep. Yet the full purpose of sleep is still mysterious. It restores energy, consolidates memory, and regulates mood. During sleep, the brain clears waste products, almost like a nightly cleaning cycle. But why evolution would design us to be unconscious and vulnerable for so many hours is puzzling. Other animals also sleep, though in strange ways. Dolphins rest one half of their brain at a time, while some birds can sleep while flying. Sleep is clearly essential. Without it, humans suffer severe mental and physical decline. But why we must dream and sleep at all remains partly unknown. 42. The mystery of aging. Why do we age? Some creatures live only hours while others survive centuries. The mechanisms of aging involve DNA damage, cellular wear, and the shortening of telomeres. But why evolution allows aging at all is uncertain. Some scientists think aging may help populations by ensuring turnover and adaptation. Others believe it is simply the result of accumulated damage with no deeper purpose. Understanding aging is not only a biological puzzle, but also a practical quest. If we solve it, we might extend human life far beyond what is possible today. 43. The maximum human lifespan. What is the longest a human can live? The oldest confirmed age is 122 years, but is there a hard biological limit? Some studies suggest humans cannot live much beyond 125 or 130 years due to inevitable cellular decline. Others believe advances in medicine, genetics, and anti-aging research could push lifespans far longer. We do not yet know if aging is an unbreakable law or just a challenge waiting to be solved. The question of how long humans can live remains open. 44. The secret of regeneration. Some animals can regrow lost limbs, repair organs, or even regenerate parts of their hearts. Salamanders can regrow legs. Starfish can regrow arms. Planarians can regenerate entire bodies from tiny pieces. Why can't humans do the same? Our bodies heal wounds, but we cannot regrow lost arms or organs. The biological mechanisms behind regeneration are partly known, but not fully understood. If we could unlock this ability, it would revolutionize medicine. But for now, regeneration remains a gift only some creatures possess. 45. The limits of longevity. Some species live incredibly long lives. Greenland sharks may live over 400 years. Certain clams survive for centuries. Bowhead whales live more than 200 years. Why these species can resist aging so well is not fully understood. Do they have special genes, unique metabolisms, or extraordinary DNA repair? Studying them may reveal secrets to extending human life. For now, the limits of longevity are a mystery written in the biology of a few remarkable creatures. 46. Frozen survival. Some animals can survive freezing solid. Wood frogs, for example, let their bodies freeze in winter. Their hearts stop, their blood turns to ice, yet in spring they thaw and return to life. Tardigrades, tiny water bears, can survive the vacuum of space, radiation, and freezing for years. How life can endure such extremes is not fully known. If humans could one day harness these abilities, suspended animation for space travel might become possible. The frozen survival of simple creatures remains one of nature's strangest tricks. 47. Cancer. Resistance in animals. Cancer is a disease of uncontrolled cell growth, but some animals seem unusually resistant to it. Whales, for example, have many more cells than humans, yet do not get cancer proportionally more often. Elephants carry extra copies of tumor-suppressing genes. Naked mole rats appear nearly immune. Why these creatures resist cancer so effectively is not fully understood. Unlocking their secrets could save millions of human lives. For now, their natural defenses remain a mystery. 48. The origins of viruses. Viruses are everywhere, infecting all forms of life. But what are they exactly? They are not fully alive. They cannot reproduce without a host. Yet they evolve and adapt like living things. Where did they come from? Some scientists think they are remnants of ancient genetic material, perhaps predating true cells. Others believe they are escaped fragments of DNA or RNA from once living organisms. Viruses may be relics of the earliest experiments in life, but their true origins remain unknown. 49. The nature of the microbiome. Our bodies are home to trillions of microbes, bacteria, viruses, fungi, that outnumber our own cells. This microbiome shapes digestion, immunity, even mood and behavior. But how exactly does it work? Why does the balance of microbes affect health so profoundly? We are only beginning to map the complex ecosystem inside us. The microbiome blurs the line between self and environment. In many ways, we are not individuals but walking communities. Understanding this hidden world may transform medicine. 50. The origin of life. Perhaps the greatest biological mystery of all. How did life begin? Did it arise in deep-sea vents, in warm little ponds, or arrive from space on comets? We know that simple molecules can form spontaneously. We know that RNA and proteins can emerge under the right conditions. But how chemistry turned into biology, how inanimate matter began to replicate and evolve, is unknown. Life may be an inevitable outcome of physics and chemistry, or it may be an incredibly rare accident. Until we solve it, the origin of life remains one of science's greatest unsolved mysteries. 51. Life's first habitat. Where did life first begin? Many scientists argue it started in the oceans, perhaps around hydrothermal vents, where hot water and minerals created the right chemistry. Others propose shallow ponds or tidal pools on land, where cycles of drying and refilling concentrated molecules into more complex forms. Both ideas have strengths and weaknesses. Oceans provide energy and stability, but also dilute chemistry. Land pools concentrate molecules but are unstable. Until stronger evidence emerges, we cannot say for sure. The first home of life remains a mystery written in the distant past. 52. The first cell's life requires cells, small compartments that protect and organize chemistry. But how did the first cell form? Scientists suspect that simple fatty molecules could naturally form bubbles, creating primitive membranes. These bubbles might have trapped useful chemistry inside, giving molecules a chance to interact and grow more complex. Still, the leap from a simple bubble to a functioning cell with metabolism and reproduction remains unknown. The transition from chemistry to biology is one of science's most elusive puzzles. 53. Why DNA? All life today uses DNA to store genetic information. But why DNA and why its elegant double helix structure? RNA may have come first, carrying both information and simple catalytic functions. Yet DNA eventually took over, more stable and capable of holding vast amounts of data. Was this choice inevitable, dictated by chemistry? Or was it a lucky accident, a path among many possibilities? The universality of DNA suggests it is the best solution nature found. But why this molecule and not another remains a mystery. 54. The origins of viruses. Viruses are some of the strangest entities in biology. They cannot reproduce alone, yet they invade living cells and hijack them. Where did they come from? Some scientists think they are relics of the ancient RNA world, while others believe they are escaped fragments of genetic code from once living organisms. Viruses blur the line between life and non-life. Their true origins remain uncertain, but they may hold secrets about the earliest stages of evolution. 55. Why some molecules became alive on the early Earth. Countless molecules formed. Amino acids, sugars, nucleotides, all scattered in a chemical soup. Yet only a tiny fraction crossed the threshold into life. Why those and not others? Was life inevitable once the right ingredients came together, or was it an incredibly rare accident? If life is inevitable, the universe may be filled with living worlds. If it was a fluke, we may be alone. This question goes to the heart of whether life is common or rare in the cosmos. 56. Life beyond Earth. Is Earth the only home of life? Despite decades of searching, no evidence of extraterrestrial organisms has been found, yet conditions for life seem abundant. Mars was once wet. Europa and Enceladus hide oceans beneath ice. Exoplanets orbit stars by the thousands. Organic molecules are scattered across comets and nebulae. The silence is puzzling. Life may be everywhere but too subtle to detect, or it may be exceedingly rare. Until we find proof, the question of life beyond Earth remains unanswered. 57. Alien chemistry. Could life be built from something other than carbon and water? Silicon is abundant and can form long chains. Ammonia or methane could serve as solvents instead of water. Some even speculate about plasma life or information-based life. On Earth, all life shares the same chemistry. But that may only be one solution. Somewhere else, entirely different biochemistries may exist. Discovering them would challenge our very definition of what it means to be alive. 58. Habitable worlds. Astronomers have found thousands of planets orbiting other stars, some rocky and in the habitable zone where liquid water could exist. But how many are truly habitable is unknown. A world needs more than the right distance from its star. It needs atmosphere, stability, protection from radiation, and long-term conditions for life. Some moons may also be habitable, hiding oceans beneath ice. Whether Earth-like worlds are common or rare remains one of astronomy's greatest questions. 59. Are we alone? For as long as humans have looked at the stars, we have wondered if we are alone. The search for extraterrestrial intelligence has scanned the skies for decades, listening for radio signals. We've sent probes to planets and studied distant atmospheres. But so far silence. It may be that intelligent civilizations are rare or short-lived. It may be that they exist but are too far away to detect. Or perhaps life is everywhere, but in forms we cannot yet recognize. The question of whether we are alone remains unanswered. 60. The mystery of consciousness. Of all the mysteries, none may be deeper than consciousness. Every thought, memory, and sensation arises from the brain. Scientists can measure electrical signals, map brain regions, and even turn awareness off with anesthesia. Yet none of this explains why experience exists at all. Why should firing neurons create the feeling of being alive? Why does red look like red, or music feel moving? Some suggest consciousness emerges when information spreads through networks. Others think it may be a fundamental property of the universe itself. For now, the mystery of consciousness remains unsolved. The most intimate puzzle of existence. 61. The origin of language. Language is one of humanity's defining features. But how and when did it begin? Did it evolve gradually from gestures and simple sounds? Or did it appear suddenly, sparked by a genetic change? No fossils record the first words. We can only infer from skulls, tools, and symbolic artifacts. Some scientists think language may be hundreds of thousands of years old, while others argue it emerged much later. Its origin is a mystery. But once language appeared, it transformed humanity, allowing knowledge, culture, and history to grow. 62. The origin of music. Why do humans make music? Rhythm and melody exist in every culture across all times. Music can stir emotion, unify groups, and even aid memory. But its evolutionary purpose is uncertain. Some argue music is a byproduct of language or emotional communication. Others see it as an adaptation for social bonding, like grooming in primates. Whatever its origin, music remains a universal human mystery, one that resonates beyond reason. 63. The birth of writing. Writing turned fleeting speech into permanent record, changing history forever. But how exactly did it begin? The earliest writing emerged in Mesopotamia, Egypt, China, and Mesoamerica. Was it invented independently each time, or did ideas spread? Why did some societies create writing while others never did? We know that tallies and symbols slowly evolved into complex scripts, but the moment when marks on clay or bone became true, writing remains partly hidden. 64. The first stories. Storytelling is older than writing, but when did it begin? Around fires, humans told myths of creation, spirits, and ancestors. These stories shaped identity and culture. But what were the first stories told? We cannot know for certain. Only fragments of ancient myths survive, echoes of tales far older. Storytelling may be as old as language itself. The mystery is not only when it began, but why humans are compelled to tell stories at all. 65. The origin of religion. Religious belief is found in every culture, past and present. Did it emerge to explain the unknown? To strengthen social bonds? To comfort against mortality? Archaeology shows evidence of ritual and burial tens of thousands of years ago. But whether this was true religion or something simpler is unclear. The roots of belief may lie deep in the human mind. Why humans seek gods and meaning remains an unsolved question. 66. The origin of civilization. For most of history, humans lived in small groups. Then, suddenly, great civilizations arose, with cities, writing, and organized states. Why? Some credit agriculture, which allowed surpluses and population growth. Others argue for geography, trade, or even climate change. But the exact path from scattered tribes to cities like Uruk or Thebes remains debated. Civilization's birth is still partly hidden in prehistory. 67. Why agriculture? Arose agriculture transformed humanity, yet for millennia, humans survived as hunter-gatherers. Why did people begin farming? It may have been climate change at the end of the Ice Age, population pressure, or chance discovery. But farming was not easier. It often meant harder work and poorer health at first. Why humans made this leap, and why in some places and not others, remains uncertain. 68. The spread of agriculture. Once farming began, it spread across continents. But was this through migration of people or adoption of techniques by neighbors? Archaeology shows both patterns, but the balance is unclear. The spread of crops and domesticated animals reshaped the globe, yet its exact pathways remain debated. The agricultural revolution is one of history's most important changes, but many details are still missing. 69. The first cities. When and why did people first gather into cities? Sites like Uruk in Mesopotamia and Çatalhöyük in Turkey are among the earliest. But the process of urbanization is not fully understood. Did cities grow around trade, temples, or political power? Did they arise independently in different regions or spread from a single source? The first cities were experiments in human living. Their origins remain a puzzle. 70. The first laws. Civilization brought rules, but who wrote the first laws? Hammurabi's code is famous, but earlier codes may have existed. Did laws emerge from custom, religion, or rulers' commands? The mystery is not only who wrote the first laws, but why humans accepted them. How cooperation became codified into rules is one of history's unanswered questions. 71. The first governments. How did humans invent government? Small tribes managed by kinship and custom. But with cities came the need for order, armies, and leadership. Did governments emerge from cooperation or from conquest and control? The first rulers left monuments but not full explanations. The origin of organized power remains uncertain. Government is now universal. But how humanity first submitted to authority is still mysterious. 72. The first money trade is as old as humanity, but money is newer. Who first created it and why? The earliest money may have been shells, beads, or metal weights. Later came coins stamped by rulers, then paper backed by states. But how did trust in symbolic value begin? Why did people accept that a coin or note stood for real goods? The leap from barter to money remains partly mysterious. 73. The first technology. What was humanity's first true technology? Was it fire, stone tools, clothing, or language? All transformed survival. But when and how these breakthroughs happened is still debated. Fire control, for instance, may be nearly 1,000,000 years old or far younger. Tools stretch back even earlier. Technology defines humanity, yet its first steps remain hazy. 74. The first art. Why did humans begin making art? Cave paintings, carvings, and jewelry appear tens of thousands of years ago. They may have been ritual, communication, or simple expression, but why did art arise at all? It does not feed or shelter, yet it is universal, part of what makes us human. The first artists left no explanations. The purpose of art's origins remains a mystery. 75. The first kings and queens. Why did some humans rise to rule others? Early leaders may have been chosen for wisdom, strength, or charisma. Over time, power became hereditary, with kings and queens claiming divine right. But how did this transition happen? When did leadership become monarchy? The origins of royalty remain hidden in prehistory. Power's first consolidation is a question history has not fully answered. 76. The first war's conflict is ancient. But when did organized war begin? Archaeology shows evidence of battles thousands of years old. But were they raids or true wars? Why humans began fighting in groups rather than as individuals remains debated. Was it for resources, power, or ideology? War is as old as civilization, but its first spark remains uncertain. 77. The origins of inequality. Why do human societies develop inequality? Hunter-gatherers were often more egalitarian. With farming in cities came hierarchies, classes, and wealth gaps. But why? Some say agriculture created surpluses for elites to control. Others blame geography, conquest, or chance. The roots of inequality remain a puzzle, one with consequences we still live with today. 78. The origins of writing. Systems writing arose in several places: Mesopotamia, Egypt, China, Mesoamerica. But how and why? Some scripts may have been invented independently, others borrowed and adapted. Did writing first serve trade, ritual, or memory? The earliest marks blur the line between record and symbol. The full story of how humans first captured speech in symbols is not yet known. 79. Lost civilizations. History remembers Egypt, Mesopotamia, China, but others may be lost. Myths speak of Atlantis, Mu, Lemuria. Archaeology uncovers forgotten cultures like the Olmec or the Harappans. How many civilizations rose and fell without trace? The earth may still hide ruins of peoples unknown. Lost civilizations are reminders of how fragile memory is. 80. The origins of the wheel. The wheel seems obvious, yet it was not invented until relatively late. Why? Early humans had tools, fire, and art long before wheels. The first wheels may have been for pottery, not transport. Later, they revolutionized carts and chariots. But why did such a simple idea take so long to appear? The origins of the wheel remain a surprising mystery of technology. 81. The spread of civilization. Human civilization emerged in multiple places: Mesopotamia, Egypt, China, the Indus Valley, Mesoamerica. But why there, and not elsewhere at the same time? Geography, climate, and resources surely played roles. Access to fertile land, rivers, and domesticable plants and animals shaped development. Yet some societies advanced, while others remained hunter-gatherers for millennia. The exact reasons for where and when civilizations arose remain debated. The spread of civilization is one of history's enduring puzzles. 82. The fall of civilizations. History is full of great societies that rose and fell. Rome, the Maya, the Indus Valley, Angkor. Why do civilizations collapse? Climate change, resource exhaustion, war, and disease are common culprits. But often, the fall is sudden and mysterious, with evidence pointing to multiple causes. Understanding why civilizations fall is more than academic. It may hold lessons for the future of our own global society. 83. The fate of the Maya. The Maya built vast cities with pyramids, calendars, and advanced astronomy. Yet by the 9th century, many cities were abandoned. Drought, deforestation, and conflict may have played roles. but no single explanation fully accounts for the collapse. The mystery of the Maya's decline remains a haunting question in archaeology. 84. The Indus Valley Puzzle. The Indus Valley civilization thrived around 2500 BCE with advanced cities, plumbing, and trade. Yet their writing has never been deciphered. Why the civilization collapsed is also unclear. Climate change, shifting rivers, or invasion may have been factors. Until their script is cracked, much of their story remains silent, locked in undeciphered symbols. 85. The Secrets of Stonehenge. Stonehenge in England is one of the world's most famous monuments. Its massive stones align with the sun at solstices. But why was it built? Was it a temple, a burial site, a calendar, or all of these? How Neolithic people moved stones weighing tons over long distances is also mysterious. Stonehenge remains a riddle in stone, a monument whose purpose is still partly unknown. 86. The Pyramids of Egypt. The pyramids are wonders of engineering, built thousands of years ago with incredible precision, but many details remain debated. How were massive blocks moved and placed so perfectly? Were ramps used or lost techniques we no longer know? The purpose is clearer, tombs for pharaohs, but the methods remain partly mysterious. The pyramids stand as symbols of human ingenuity and unanswered questions. 87. The Lines of Nazca, Peru. Vast lines and shapes are etched into the desert floor. Animals, plants, and geometric figures, visible only from the air. Why did the Nazca culture create them? Theories include astronomical calendars, ritual pathways, or offerings to gods. The line's scale and precision make them one of archaeology's greatest enigmas. 88. The Easter Island statues. Easter Island is covered with giant stone statues, called moai, carved centuries ago. But why were they built and how were they moved? Theories suggest they represented ancestors watching over the island. But moving the statues, some weighing 80 tons, remains puzzling. The culture that built them also collapsed, perhaps due to deforestation and conflict. The moai stand as silent witnesses to a vanished way of life. 89. The voyages of the Polynesians. Polynesians sailed vast distances across the Pacific, settling islands thousands of miles apart. How did they navigate without compasses or maps? They used stars, ocean swells, bird patterns, and cloud shapes to cross enormous distances. Their achievements rival those of any explorers in history. But exactly when and how they spread across the Pacific remains partly mysterious. 90. The Fate of Atlantis. Plato wrote of Atlantis, a great civilization that sank beneath the sea. For centuries, people have searched for its remains. Was it purely myth, a story to make a philosophical point? Or was it inspired by a real place, such as Crete and the Minoan civilization destroyed by volcanic eruption? Atlantis remains more legend than fact, yet the dream of a lost civilization beneath the waves continues to fascinate. 91. The Origin of Writing. Systems writing appeared in Mesopotamia, Egypt, China, and Mesoamerica, but how did it truly begin? Early writing may have started as tallies, trade records, or ritual symbols. Over time, they grew into complex systems with grammar and literature. Why did writing emerge independently in some cultures but not others? And why did some systems vanish, like the undeciphered script of the Indus Valley? The full story of writing's birth remains incomplete, a human invention that turned memory into history. 92. The mystery of numbers. Numbers feel universal, but where did they come from? Ancient people first used marks to count goods or track the stars. From this came symbols, then systems of arithmetic, but numbers are more than symbols. They capture deep truths about the universe, prime numbers, infinity, and equations that govern nature. Why mathematics describes reality so perfectly remains an enigma. The mystery of numbers lies not only in their history, but in their uncanny power to reveal the structure of the cosmos. 93. The invention of 00 may seem obvious today, but it was revolutionary. Ancient Babylonians had a placeholder, but true zero, a number that meant nothing yet held value, was invented in India. How did cultures grasp such an abstract idea? Zero made modern mathematics possible, enabling algebra, calculus, and computers. Yet the path to its invention is still mysterious. How humans first conceived of nothing as something remains one of history's strangest intellectual leaps. 94. The power of infinity. Infinity is simple to imagine, but hard to grasp. Does infinity exist in reality or only in mathematics? Are there infinite stars, infinite universes, infinite time? Mathematicians wrestle with different sizes of infinity, from countable numbers to uncountable sets. In physics, infinity often signals the breakdown of equations. The concept is at once useful and paradoxical. Infinity may be real, or it may be an illusion of thought. Its true nature remains unsettled. 95. The unsolved riddles of prime numbers. Prime numbers are simple, numbers divisible only by themselves and 1. Yet they hide deep mysteries. Their distribution appears random, but with hidden patterns we cannot fully explain. The Riemann hypothesis, one of the greatest unsolved problems in math, seeks to describe their order. Primes also underlie modern encryption, protecting digital communication. Why primes behave as they do, and whether we will ever fully understand them, remains a central mystery of mathematics. 96. The puzzle of conscious machines. Could a machine ever truly think? Artificial intelligence grows more advanced, able to generate language, art, and even scientific discoveries. But is this intelligence or only imitation? Can consciousness arise from circuits and code, or is it unique to biological brains?
If machines become self-aware, how would we know?
The question of conscious machines is not only scientific, but ethical. It challenges our definition of mind and what it means to be alive. 97. Free will versus determinism. Do humans truly choose, or are all actions determined by physics and biology? Neuroscience shows that the brain may decide before we are aware of it. Physics suggests a universe ruled by cause and effect. Yet our experience of making choices feels undeniable. Some argue free will is an illusion. Others believe it may emerge from complexity or quantum uncertainty. The question of free will touches science, philosophy, and daily life. Whether we are free or determined remains unresolved. 98. The possibility of time travel. Science fiction dreams of time travel, but could it be real? Relativity allows time dilation. Travel near light speed or in strong gravity slows time. In that sense, time travel to the future is possible. The past is trickier. Wormholes or closed time loops might allow backward travel, but paradoxes, like changing history, loom large. We do not know if time travel will ever move beyond imagination. But physics does not entirely rule it out. 99. The end of time. Will time itself ever stop? If the universe ends in heat death with no change, time may lose meaning. Some theories suggest time is not fundamental at all, but emergent, like temperature. If so, time could fade when the universe no longer changes. Others believe time is eternal, stretching endlessly into the future. The fate of time itself is one of the strangest questions science can ask. 100. Why there is something rather than nothing. The final mystery circles back to the beginning. Why is there something instead of nothing? Science can describe how the universe behaves once it exists. But why existence itself arose, why there are laws, particles, and space instead of emptiness, may be beyond science. Philosophers argue that nothing may be unstable, that something must always exist. Others suggest the universe is simply a brute fact. Whatever the answer, the greatest mystery of all may be existence itself. From the birth of the cosmos to the depths of the human mind, from mathematics to mortality, the universe is filled with questions we cannot yet answer. Each mystery is a reminder that science is not finished, but an unfolding story. Perhaps one day some of these puzzles will be solved. Others may remain forever beyond us. But in every mystery lies wonder, and in wonder the spark that drives us to keep exploring.